Good morning and good afternoon, everyone. Welcome to the weekly Wednesday webinar series presented by Hawkridge Systems. Today's topic is seamless ECAD MCAD integration with specifically SolidWorks PCB. My name is Scott Davis. I'm the SolidWorks PCB product manager here at Hawkridge Systems, which includes two products. We have our standalone SolidWorks PCB, fully integrated library development for schematic symbols and PCB footprints, along with schematic editing capability, full layout capability, including the seamless integration. And then the secondary product is that very same seamless integration with SolidWorks PCB Connector, exclusively for Altium Designer. So for those of you in your organization that may be using Altium Designer, you can be rest assured that the seamless integration that we're going to demonstrate today works exactly the same with Altium Designer. So why use SolidWorks ECAD MCAD solutions? All of today's products are typically highly mechatronic, which is the new word for integrated electronics with mechanical enclosures, cases, rack mount systems, backplanes. Anything typically designed is going to have some mechanical enclosure, and the challenges are how do we fit our electronics into these mechanical enclosures to ensure that connectors are in the right places, mounting mechanisms are in the right places, and we don't have any clearance issues. So having a seamless integration between your PCB design and your mechanical enclosure assures that you can achieve these goals. And we also give you full editing capabilities with SolidWorks once you have collaborated your PCB design from a mechanical perspective. And we'll demonstrate that today. So with the addition of our electronic design product, SolidWorks PCB, the ecosystem now provides every solution for you during your product development cycles. Today, we're going to be focusing on the mechanical design and the electronic design with SolidWorks PCB. We are using the version 2018 software, which includes many enhancements and some great features and moving forward. As I mentioned earlier, SolidWorks PCB is full schematic capture capability, creating your electronic net list, your part list, your bill of materials, all your component definitions, all your component parameters. And then you associate that schematic to the layout tool, which is going to provide you with full circuit board design capabilities. Again, along with all of the necessary manufacturing outputs to create that bare PCB and also get that PCB assembled by your contractors. The product includes the real-time collaboration. So it's essentially pushing and pulling files to and from SolidWorks. Once you're in the SolidWorks environment, you're going to have a three-dimensional model of your printed circuit board with editing capabilities for component placement, board outline adjustments, mounting hole mechanism adjustments. And then you simply push that back to the SolidWorks PCB tool, and you will visualize real uptime, updated edits. Okay? So today we're working on two projects. We're going to start with this Adreno board. It's a multi-board project, so we'll be working on the main board. Then we're going to collaborate that to SolidWorks assembly, and we're going to mate those assemblies together, and we'll adjust the range finder connector, and I will show you how that automatically updates inside of SolidWorks PCB. The second project is to utilize SolidWorks to create the board outline, insert the slot, push that back to PCB so that we can add some simple mechanical components and then we will load that into a new assembly and make some connector adjustments using SolidWorks, and again, have that automatically update our PCB tool. So with that, let's close the presentation and let's get into the software. Okay. So this is the SolidWorks PCB user interface. This is not new technology. This is a very stable tool. It's been on the market for quite some time. It does have a new user interface. It's a more SolidWorks inspired interface. So it's all tab driven and ribbon driven with simple icons that are easily found to execute the commands. All of the editors within the tool are available. So we have our schematic editing tool, which we would use to create individual schematic symbols. We also provide you a symbol wizard, so you can quickly define your symbols and add them to your library. Or you can copy symbols, modify those, and add those to your library. So library creation is extremely efficient. Library creation for footprints is also extremely efficient, and we give you the same type of wizard for footprint development, which is based on IPC standards. SolidWorks PCB is a three-dimensional visualization layout tool. So you can place your components in the three-dimensional mode. Simply by clicking the number 2 and number 3, we are switching between our two-dimensional view and our three-dimensional view. The models that are embedded onto your SolidWorks PCB footprints are the models that will directly collaborate to SolidWorks. Okay? You have the capability to add SolidWorks part models, step files, parasolid files, or you can use the internal 3D model creation tools to develop your own models within the PCB tool. Okay? We're going to first quickly complete this schematic circuit because I want to show you how productive and how efficient the tool is to complete this circuit. Then we'll associate that to the PCB, quickly place the components, do a little bit of trace routing, just so you kind of get a feel for the functionality of the tool, the ease of use. But again, today's focus is really this mechanical collaboration, okay? How do I get this to and from SolidWorks with accuracy and efficiency, okay? So let's quickly get these parts on here and I'll wire up the schematic and then we'll move into the layout, okay? Parts are easily added from the library. You can simply drag and drop them from the library, or I can select the component and I can say place component as well, okay? I am going to drag and drop a few of these and then I'll use that other mechanism to add additional parts. So with our part highlighted, we can simply just drag and drop these components onto our schematic. Grab a couple capacitors here, get those placed, and then we'll finish that up with the crystal and a few resistors. Navigation in the tool is extremely simple. You can zoom in and out with your control wheel. You can pan with the right mouse button. So again, real easy to navigate around and add components. So for the resistor, I will place resistor. Now when I place the resistor, I'm going to get additional resistors on my cursor. And I can change those reference designators just by changing the text. Okay? Then automatically by changing the text to R3, R4 automatically comes to the cursor. Okay? So we have all of our components placed. Now we need to wire up our schematic. Again, wiring is extremely easy. I can go to the Home tab, where most of the commonly used commands are going to be found. Wire, place net label, power ports. If I need to add power ports, I have all these available to me. You can do harnessing, hierarchical blocks, multi-channel. A lot of functionality in this schematic tool. Like I mentioned, it's a complete standalone circuit board creation tool unto itself. Okay, but the value is the collaboration with SolidWorks. So we'll just go to the wire command. Now we're in the wire mode. When we highlight and hover over an active pin, our cursor turns red. So I'll just quickly get this schematic wired up, and then we'll associate this to the PCB. Again, I'm continuing in the wire mode. SolidWorks PCB is smart enough to know when I end connections and when I can move to a new connection. Okay. And we have multiple draw modes. I'm in the 90 degree right now, but we can do a shift, and I can do 45s. I can do full orthogonal, or I can do highlight where to. But typically, you route schematics in the 90 degree mode. You're going to have those same modes when you route traces, with one additional mode. You're going to be able to route arced traces with the PCB tool. Just a couple more connections here, and we'll have this guy completely ready to go to our circuit board layout. Okay, so there we go. We have our circuit completed. We have a multi-sheet schematic here. So now most everything is already associated to our PCB, which we'll be working on here. Now what I would do is just bring in those components. Let's turn off that. We do an import. Now on every import, you're always going to get an engineering change order list, right? So it's describing to me what's being added, both from a component standpoint and from a wiring standpoint. So we're going to execute those changes. Okay. Now we've added all these components. We'll move them over to the area where we can quickly place them and do some simple routing. By grabbing components and making them active on the cursor, this is where I would do rotations. And also this is where I would flip the component from the top to the bottom. That's important because the surface at which the component is placed is the surface at which it represents in SolidWorks. So we just quickly drop those in. Now we'll look at routing some of the traces and the capabilities there. So you can see we have the guide wires here for the connections. And again, in the PCB tool, just like the schematic editing tool we saw, all of the most common commands are going to be found on your Home tab. You also have a View tab for viewing, zooming in. Your Project tab allows you to add multiple documents and add libraries, and also import and export your design. Okay. Additional tools are available. SolidWorks PCB does contain an auto router, so you can quickly auto route your PCB designs and set up your own auto router stack or auto router pass information for those of you that have used auto routers before. And then you have a completely separate output tab for all of your manufacturing files, all of your mechanical files if you choose to have standalone mechanical files. But with the collaboration, we're going to seamlessly send the file to SolidWorks. So I go back to my Home tab and I do some route connections. Again, when I hover over active pins, you can see that the cursor puts a round circle, and that tells me that's an active pin. So I can bring this off, and that the trace width looks fine for this component, but being a power trace, I'm probably going to want to make it a little bit larger. So those wire modes I mentioned for schematic, again, they're the same in the PCB tool. There would be our arc routing mode. we would have 90 degree, and then you have full orthogonal as well, okay? Which can be helpful when routing shortest distance for printed circuit boards. So we'll go ahead and put in our first corner, and we'll now switch this trace width to something doubled in size, okay? Now the other feature of this tool is that if there's a clear path to complete the route, which in this case we have a clear path to the power pin of the battery, you can do a control left mouse button and it'll finish the route for you. So you don't necessarily have to make all the clicks and end at the pin. So if I do control left, it finished that route for me. That's very handy and again, very efficient. Now our trace width remained at 20 because we set to 20. So we'll drop it back to 10. And we'll just route up this guy. And again, control left key finishes that. We can bring this off, finish that, route some power traces, and again, quickly and easily connect up our circuit so that we can finish the design for manufacturing and prepare to go to SolidWorks. Okay? So how do we get this design in SolidWorks? I mentioned previously in the library that SolidWorks is a three-dimensional visualization tool for PCBs and footprints. So again, by clicking the number 3 key, that's our three-dimensional view of this particular design. Okay, this is what we would expect to see in SolidWorks. I can absolutely move components and position them in the three-dimensional mode within SolidWorks PCB. So SolidWorks PCB includes what we call the connector. Okay, the operation of this functionality is driven by an installation of a database onto a network server. So the SolidWorks users with their username and login would connect to that database. SolidWorks PCB users connect to that database. And now you can see here that we have simple push-pull buttons. One big advantage of this tool, SolidWorks PCB can collaborate with as many SolidWorks users that are within your organization. There is no licensing required at all for SolidWorks 3D Mechanical CAD. Since 2016 Service Pack 3, that functionality is built into every version of SolidWorks as an add-in, and you simply just turn it on and then connect to the server. All right? So let's push our board and tell our mechanical engineer that we've got a new PCB assembly. Now the synchronization is based on the project name. So today we're using PCB Experience. The other project we saw on the slide will be Project A. And we'll come back and we'll demonstrate how to use SolidWorks to create that outline. All right. So let's close down PCB now and switch hats and become a mechanical engineer. So we start with a blank SolidWorks session. Okay. Under Tools, I mentioned add-ins. Okay. Everyone has this capability now. You simply turn it on. It's going to add a new icon over here for your SolidWorks right-hand panel. By clicking that panel, you make your connection to the database, and we do what's called pull board. So by pulling board, we're actually looking in the database. We're seeing multiple projects that we can now create SolidWorks assemblies. Okay. We knew we were working on PCB Experience. I've got to save my file. And now SolidWorks is going to create its normal SolidWorks assembly structure. I've got the high-level project name, and I've got subsequent SolidWorks part models for all of these components in a three-dimensional CAD tool, right? So I have my board, and I have each individual component that I can actually move and edit in this assembly, but I can also take this assembly and I can load it into a higher level assembly. which that's what we're going to do today. So we're going to open up another project. Which is the case and the other previously collaborated baseboard. Okay, so here's our chassis with our baseboard. Now we can bring in our daughter card and associate these boards together. Okay, by simply using normal SolidWorks commands, we can reference these two assemblies together to ensure that there's proper fit. Okay, so we just match up the mounting holes first. Okay, now we have board-to-board connectors, right? So we take the back surface of our board and we say that we need that inserted into the surface of this connector. But the manufacturer gives us the exact distance, 3.2 millimeters. Okay. So with the 3.2 millimeter offset, you can see now that we have that assembly similar to the presentation slide. However, we've got collision of the rangefinder into the chassis. So we can use SolidWorks evaluation tools and do an interference detection, and it will highlight this particular area. Okay. Now it takes a little bit of time in some instances, so because we're on the web, we're doing a quick demonstration. I'm just going to go ahead and edit the assembly and modify that component. Okay, so now we're in the edit mode for the main assembly. I highlight the component and I tell it that we need to move it triad, right? Because we just need to move it in the Y dimension about, let's go 2.4 roughly. All right, that's close enough. So again, we could use SolidWorks tools to dimension it, center it, however we like. But for ease of quickness, right, we just visually centered it. Now our rangefinder connector is perfectly positioned. So now how do we get this back to the PCB tool in real time? And again, you can see we definitely have created additional collisions. So we could move these push buttons out of the way in SolidWorks, or we could certainly do that in the PCB tool as well because they're already routed components. Okay. So now by opening this assembly, okay, we can see we still have that same detection or collision detection. And now by opening the connector panel again, we are pushing this information. Again, there was my original note. You have full project history of communication. We now push this to the server and we say that we have moved H4. Now, if you're working in an active assembly, either in SolidWorks or SolidWorks PCB, and you open the connector panel, the tool is smart enough to see that there's new data, and it will notify you automatically. Close this guy down. And we'll come back for our second project. So back in the PCB tool, okay, we can go to the 3D mode, and we can open up that connector panel. And there's that notification, moved H4. We don't do file import export, okay? We're working on the real data. I mentioned that we give you visualization to see what's going on. So by view changes, you can see that H4 was moved, and by clicking H4, I get animation showing me where H4 is moving. Okay, it's all real time. So we accept that change, and instantaneously H4 moves, and then I go back to the two-dimensional view and definitely see that I would have component movement to clean up, trace routing to clean up. But once I finished that, I could go back to SolidWorks in that same assembly and release my full mechanical assembled design. Collaboration allows you to collaborate multiple boards into one SolidWorks assembly because, as we know, many products are multi-board products. All right? So that was a simple connector movement. So let's look at our next project. How do I utilize SolidWorks to create board outlines or move mechanical components? All right, so we're going to start with a blank circuit board. We have a simple 5-connector schematic because the focus here is mechanical items. Okay, so we're going to utilize SolidWorks to make sure that we've got these 5 connectors in the correct position. But first, we want to create the mechanical outline with SolidWorks. A feature of the tool is when you look at your circuit board layer stack up, which defines your layers, your dielectric thicknesses, you get an overall thickness. Okay, this board happens to be 062 or 62 mils. That's pretty common circuit board thickness, along with 125s. I mean, there's definitely some industry commonality there. SolidWorks reads this thickness and creates the board exactly as you have defined in your layer stack up. So that's an important feature. You'll want to set that up first. We use the same process. Go to the View tab, open our connector panel, and we're going to tell SolidWorks that we have a new board. And we'll simply post that up. We'll switch back to SolidWorks again. So as our mechanical engineering counterparts would know, you could send them a quick message, but as soon as you start collaborating multiple assemblies or multiple iterations, that communication is going to be automatic. But for the very first pull, you have to let them know that, hey, I just put a new design on the database. So same process, right? Pull board. There's our list of projects. Now we're working with PCB project A. So let's save that assembly. Okay, there's our blank board. Again, the 062 or 62 mil thickness, that's actually the only dimension that is on that sketch inside of SolidWorks. Okay. So from here, I'm going to insert my chassis component. Now this particular chassis, it's not completely designed, but my goal is to use the bottom surface that I have defined as my board outline and include the sketch. When I iterate the second time, I'm going to utilize a newer, updated, modified chassis, but I can still reference it to the features of the PCB and match that up to my new chassis. Okay. So let's reference these two parts together. Okay. Now we're able to slide, obviously, the chassis anywhere we like on the surface of the PCB, and we won't lose that reference, right? So by dropping that down, we're good. Now we just simply need to edit the board sketch. Okay. We can delete the perimeter because we're going to use this inside surface, and we're going to make that the board. All right. So now in 2 clicks, we've got a board with slots. We're going to put the cutout in. We've got arcs. We've got angles. I don't care which PCB tool you're using today. This is not an easy board outline to draw inside of a PCB tool. Now, you may be able to convert a DXF and other items like that, but how do you ensure the accuracy, right? By using SolidWorks to create the board, we know it's 100% accurate. So let's edit this part and sketch in that slot. right? We convert that. Now we simply use SolidWorks extrude cut feature, and we cut away all the material. Do a quick rebuild, go back to our assembly, full model, right? Now we have our slot that matches what we developed in SolidWorks. Okay? So let's get those other remaining components onto the board and bring this back to that updated chassis for the next level assembly. So again, we just push. Again, there's that comment, had a new board, and all of the history. So we adjusted the outline, but I need the PCB designer to add mounting holes so that when I bring the board back in, I can position those mounting holes onto my updated chassis standoffs. Okay, so add 3.1 MTGs. Now my PCB designer is going to see that note real time and add those PCB holes for me. All right, back in the PCB, we could have been doing things like additional schematics or even, some routing if the components were there, anything that wasn't affected by the board outline or the slot location. Open our panel. There's my note that says adjusted the outline and I need to add those 3 holes. Let's look at the visualization again. There's the new outline. Here's the slot. Now this happens to be the chassis. You can send SolidWorks parts that you add to the assembly. You can send those back to the PCB, and you can pick and choose whether or not to bring those into your circuit board design. In this particular case, I'm not going to bring the chassis in at this time because it's not the final one. But by doing a right-click check all, I can then just turn off that chassis. So with one click, instantaneously again, there's my new outline with my slot, created by SolidWorks. So now we go back and we import the changes. Again, there's our ECO, adding 5 parts. Okay, so let's get these parts on the work surface and push this back to SolidWorks so that we can check the verification of placement and adjust if necessary. And there was that note to add 3 mounting holes. So on the Home tab, I would add pad. Okay. Check my pad parameters. Hole size needs to be 100. Say OK. And we don't care where we put them in PCB. We didn't get no dimensions. We weren't instructed where to place them because we don't care. We'll let SolidWorks deal with that. Okay. So we added the parts, we added the holes, quick 3-dimensional view. That's kind of what our SolidWorks model is probably going to look like. So we can go now push this to SolidWorks. And we can say that we've added the parts and the MTGs. All right. So let's get into SolidWorks now. In the meantime, I mentioned I've created a new chassis, modified one. My surface bottom still the same pattern because I knew that's what I wanted initially. So I'm going to create a new assembly again using that same project. Just overwrite my other file. Now this assembly tree, and some of you may be used to using step files and other methods to get your circuit boards into SolidWorks, but by using the collaboration, you now have a much more intelligent assembly tree, right? I've got each component, and it's telling me the reference designator for each of those components. Okay, so now I'm going to add my new chassis, and we'll match that up and do some checking for interference. Okay, quickly again, we're going to take the surface of our standoff. Okay, and that needs to be referenced on the back of the PCB. And now what we can do is we can reference the slot faces together to ensure that we have that relationship correct. All right. Again, simple 4 clicks in SolidWorks. I've now got that new board into the updated chassis, and now I've provided that board to chassis clearance, and I've added a slot for the power connectors and my audio connectors. So let's do that evaluation of our interference with SolidWorks tools. And when we calculate that, right, SolidWorks immediately tells me, hey, you got a power pin going right through your chassis. That's not going to work. So let's just move the component in SolidWorks and have that automatically update the PCB. Again, I can do this dimensionally, visually, reference, however I like. I'll just do it visually for ease of time. But by doing it visually, I do have it fairly accurate. Okay? So again, I can now update my PCB with that. But before I do that, I need to move these mounting holes to match my standoffs. So inside of the board part, right, the separation between all through holes and models occurs. So all the holes are now part of the board part, but the models remain individual SolidWorks parts. So we just simply edit this sketch. Okay. We can change our view to the wire mode. Now in SolidWorks, I can drag and drop this anywhere I want. I could create dimensions. I can also change its diameter. If I change that whole diameter in SolidWorks, it will absolutely update the drill value in the PCB tool, because your PCB vendor is going to go off of your NC drill file to drill the board, obviously. So there is a direct correlation between the diameter in SolidWorks and your drill size value in the PCB tool. So let's just drop these other two together, and then we'll push this back. Now in doing so, I can also, do some experiments and have my PCB designer maybe look at some suggestions I might have mechanically. Because we give you the view and accept reject capabilities, you don't have to make changes. You can absolutely reject them. So maybe I want to take a look at moving audio connectors up into this area. Maybe I could shave chassis material. Maybe I could save some PCB material. So I would push this back now and say that we move the power and the MTGs and review audio placement. Again, there's all my history. I post this. Okay. Now we're going to continue in this assembly this time. We're not going to close it down. But in SolidWorks PCB, by opening the panel, now I get a whole list of changes, right? All right, so with animation, we can see where every mounting hole and every connector is going. So I can see that the power connector looks okay, but I don't know really what's going on with these audio jacks. Again, he said review that. So I've reviewed it as the electrical engineer and said absolutely not, because I have plans to put magnetics or additional power circuits or maybe digital circuits up in that area. So we're not going to be able to take a look at that today. But we can take a look at the movement of the mounting holes. Now, if you had routed connections to any of these connectors and you move them in SolidWorks It will not jeopardize the integrity of the electrical connection. It'll just create a new guide wire like we saw in the first project. It'll create a new guide wire from the end of the route to the location of the new pin. Okay. So we're going to go ahead and accept everything. We're not bringing the chassis in again, but we're also not going to move, what's this? Okay, we're not going to move J4 and J3 because those were the audio connectors. Now accept that. Okay, quickly done. I would go ahead and finish my board, do all the routing, do all the documentation, and then always, as the final iteration, I would collaborate this to SolidWorks to get that final assembly. That can also allow you to release your mechanical assemblies, including your electronic assemblies, with bills of materials, with documentation, side views, front views. All that is capable inside of SolidWorks now that you're sending real data. So we'll push this back and we'll just say that we've got this as the final PCB. All right. Now we give you that same animation inside of SolidWorks. So you can see what's being moved here is that J3 and 4, they're going back to their original location. Okay. Now it's not going to bring in the reference board because that's the chassis. It's already in my SolidWorks assembly. That's why the color of the box is pink. Okay. So I am going to accept the changes to move the audio connectors back to their original location. Rebuilds the part and rebuilds the assembly. Okay. So that's how you perform seamless integration between a circuit board design tool, SolidWorks PCB, and SolidWorks 3D Mechanical CAD. All right. What I'd like to do at this point is I'd like to open up the forum for any questions that you may have. We got a little bit of time. We're right on time at 11:45. Does anybody have a question that they would like to ask regarding what you have seen today? Any questions? No questions? Easy crowd. All right, I'd like to leave you then, if there are no questions, I'd like to leave you with one more thought. I'm sure all of you, if you haven't seen it already, you're quickly going to be aware that SolidWorks has an amazing promotion going on right now exclusively for electrical products. If you purchase any of SolidWorks electrical products, including PCB and the PCB connector, you can acquire additional SolidWorks products at 50% off. And that is an unheard of promotion. So if you're interested in that, want some more information, certainly reach out to your account manager and they can outline that for you and have those discussions. If you'd like to see a more personal one-on-one complete SolidWorks PCB demonstration, we can certainly provide that to you as well. So with that, I'm going to go ahead and conclude today's Wednesday webinar. I'd like to thank all of you for joining, taking time out of your busy day. And again, if you have any further questions, please just reach out to your account managers. Thank you very much.